Hi everyone, me again. So last time we did part A and part B, which was about critical values, an introduction to what hypothesis testing was, and the last two parts are, I think, the easy parts really, which is about one-tail tests and two-tail tests. So let's get into the video. By the way, my channel isn't a maths channel, but I'm just doing this for the time being because I think it might help some people. So yeah, just putting it out there in case you're subscribing just for maths. So a one-tail test just simply means a hypothesis with one direction only. So the steps that you use in these type of questions is basically the same as the steps I mentioned in the last video, but I will repeat it here, and I will use basically the more complete sentences which the book uses. By the way, it's the Edexcel textbook. So first of all, you formulate a model for the test statistic. And basically what this means is basically decide if you will use binomial or normal distribution. If you're in year 12, then you haven't learnt this yet, but you will. Oops. Because basically for A-level you only learn binomial and normal distribution, but I bet it's like Poisson distribution and something else in like other stuff. So if you're other areas like further maths, so if you're doing that, then you have to learn that. But we are doing A-level, so oops, that's bad. And then you have to identify suitable null and alternative hypothesis. And what basically this means is from the last video, we knew that basically it's H0 and H1. And H0, and remember that you always assume H0 is true. I mean, at the beginning, or at the start. I think
I'm going to change it to 1, 2, and 3. 1, 2, 3.
Part 3 is you have to calculate the probability, so you finally have to do the number crunching. Calculate the probability of the test statistic taking the observed value or higher, lower, assuming H0 is true. Yep. So by the way, all this is from the Edexcel
textbook, okay? Not mine, in case you guys, in case I don't do any law thing, I don't want to be sued just for copying out this.
I'm trying to explain it in my own words, but I think the textbook is very helpful in explaining all of that as well. But I think like textbook plus your own words is basically the best in learning. So what this means, calculate the probability of the test statistic taking the observed value, assuming it's true, is basically the main step where you use your calculator to find the probability. And basically we call the probability the p-value. So it's about finding the p-value. Which, I think this one is easier to explain when you actually do it, when you actually do the questions, because remember, learning is all about doing and not really just listening and learning. Learning comes from doing. And then after you find the value, you have to compare compare the p-value to the significance level. So, for example, our 5% significance level, oops, that doesn't. So, for example, a 5% significance level, and you find that p equals 0.04, or maybe in another case 0.06, and because 0.04 is, okay, so basically what you would write is always like this. This is the first step. So I know that it doesn't make sense yet, but it's just important that you always remember that it's always in this direction, okay? And after you write that, you then, so this is just comparing, okay? You have to really write down every step, because if you don't, then you risk losing marks, and you don't want that. Probably most of my marks come from working like the steps instead of the actual answer. And the last one is you have to write a conclusion. Write a conclusion in the context of the question. This is so important. In the context of the question. The easiest way to lose mark is to basically not look at the context. So we need, you have to really pay attention to the context. So for case A, clearly 0.04 is less than 0.05, and so what this just means is that in case A, it means A means there is enough evidence to reject H0. Whereas for B, it means that there is not enough evidence to reject H0. And what we mean by when there is enough evidence, just so there is enough evidence to reject H0 means that there is evidence that what this event found is that the results are due to chance, and so the original hypothesis is wrong, and that there's a new value that is right. And B means that there isn't enough evidence to show that the finding was due to chance, so we can't reject this, and that H0 is an accurate value. So there isn't enough evidence in the case of B. Now, does this look okay? So they're just the basic steps for the questions, and I didn't really talk about one-tailed tests because all you need to really know is to use the right alternative hypothesis. And for one-tailed tests, it's always going to be either like greater than or less than. Let me just note. All you need to know about one-tailed tests is that H1 will always be in the form H1 P is bigger than X or P is less than X in this chapter. And obviously you have to, follow on for the main part of the question using like this, but essentially that's really what this section is about. And then we can go on to do a question. This is from the textbook again. I do not take any credit because I do not know how to make questions. So, question 10 from exercise 7C. A polling organisation claims that the support for a particular candidate is 35%, revealed that the candidate will pledge support for local charities. The polling organisation thinks the level of support will go up as a result. It takes a new poll of 50 voters. Using 5% significance level, find the critical region. In a new poll, 28 people are found. That's question A. And question B, in a new poll, 28 people are found to support the candidate. Comment on the observation. Again, I will put the same music and give you a minute and a half to finish this question, and don't just skip if you kind of, give it a try, and I'll come back and explain. Okay, so as always, we have to basically skim through the question and then see if we can identify any key stuff, and then we use the steps to do the questions. So we know already immediately, straightforward, that this is definitely going to be H0. And then it's revealed that the candidate will pledge support. This is just context. Context. And they think is a good kind of preparation to say that this is going to be, so it's a hint that the following info is about H1, and they think that it will go up they think it will go up as a result. So, and this means basically, if you don't know, that H1 P is going to be bigger than H0. And then it takes a new poll, it takes a new poll of 50 voters, which is for part B. So, using the 5% significance level, we know that it's 5%. You have to find the critical region. So using the steps from before, number 1, formulate the test statistic. So to formulate the test statistic, so X, the test statistic is going to be the number of people who support the candidate. So So the test statistic is the number of people who support the candidate. So basically, this is going to be big X. So how you would write it is let X be, sometimes I write the random variable. Now, I'm so used to it, I usually write it anyway, just in case I need to add it, but I don't think you actually need it. So let X be basically the number of people who support the candidate. And then, so that's step 1. But then you have to say, because this is going to be a binomial distribution, obviously, because that's all you've learned so far in this chapter, and you write a binomial distribution like NP, right? But in this case, N is 50. Yeah, because of this, right? So it is actually important for part A. N is the size of the sample. So binomial distribution. So yeah, after you've learnt normal distribution, they're gonna these act as good hints to show you which to use. So X is the 50, yeah, and then P is going to be 35%. However, very important is that you do not just say that this is 35%. Actually, you should normally put it in you should put it as a decimal, my bad. 0.35. But yeah, you shouldn't just write that. You have to also add, assuming H0 is true. And then you write H0. So H0 is the p-value, p equals 0.35. So basically H0 is like the results before event X, let's not use X, event V happens. And then H1, which is after the candidate said, oh, we're going to support charities if you support me. After saying that, then H1, which is the result after, they think that this level of support will increase. So P is going to be bigger than the old value because it increases. So the results after event V happens. And in this case, event V is the reveal that the candidate will pledge support. Basically, will support local charities. Yeah. So basically, the event is that the candidate says that he will support local charities. For example, the Prime Minister might say, if you vote for me, then I will lower the taxes for the rich. Not saying anyone in particular. And so that is step 2, hypothesis. And then step 3, you have to calculate the probability of the test statistic, which is the main part. Finally, we get to this part. So, Oh, but basically, yeah, the main part is actually finding the critical region. Okay, it's not actually like calculating anything. Yeah, it's finding the critical region. So if you remember from the last video, which you should go and watch if you haven't, is that you can either use tables. Okay, so method
for 1, 2, 3 is tables for
calculator. Now I'm assuming that you guys are watching this, either you guys know how to use a calculator or maybe your teachers have told you, but if they haven't, then you can just Google it quickly, because, or you could, like, I would teach everyone who I normally tutor, but yeah, I'm just assuming that everyone here knows. So yeah, so use a calculator. Well, I would use a calculator, and basically it's just trying out different numbers until you find a value that is close to less than 0.05, which is less than 0.05. So we could, now this says it will go up, so it's a one-tailed test. The form, it will always be, because okay, let me just write this down first. So the probability of x is bigger than a certain number is going to be less than 0.05. Now basically, if h1 p is bigger than, let's call this maybe like y, then you would write probability that x is bigger than a. Is less than like 0.05 or something. But the key I just wanted to point out is just this one. And yeah, so where can I write this? For binomial, it's always less than or equal to, and not that for this form. I always got it wrong. I mean, I didn't always get it wrong, but I would always get it mixed up. So I'm just basically teaching from my mistakes. But if you think what I'm saying is just like easy common sense, then I'm just dumb. So yeah. So where were we? So yeah. So after, try a few, so you can use your calculator to try out different values until you get a value close, a value that's less than 0.05. And you normally you normally find out quite quickly. So it's not like if there's 50 values, you have to try all 50. You normally find it pretty quickly once you get around a close number. So after trying out through a few, you would find p x is bigger than 23 is going to be 1 minus p x is less than or equal to 22. I will explain this later, which equals 1 minus 0.9290 equals 0.071. Now this is obviously bigger than 0.05, However, it's close. So maybe you might want to try a different one. For example, x is bigger than 24. And then you would get 1 minus probability x is less than or equal to 23, which is going to be 1 minus 0.9604 equals 0.0396, which is actually less than 0.05. And so, this is the right answer. And then number 4, so that's number 3, and then that's number 4. So you compare it. And then number 5 is write a conclusion. So the conclusion is just going to be that the critical region is x is bigger than or equal to 24, because that is what you get. Now, as for this area that I said I would explain more about, should I use this colour? Doesn't really match, does it? I think I'll just go back to this one. This and this. Also annoying. So just remember that, a probability, any probability, is from 0 to 1, which means that therefore, the probability that x is bigger or equal to a is always going to be 1 minus the probability x is less than a. No, a is less than a minus 1. And you would use this in normal distribution where it's bigger than a, so not bigger or equal to a, then you would get 1 minus the probability x is less than or equal to a, because 1 minus the rest of it, and this one does not include a, so you need to do 1 minus p x is less than or equal to a, including a. I'm just emphasizing this because I made the mistake so many times of not doing that. So, yeah. And the same for less than a. It would be 1 minus p x is less than or equal to a minus 1. Oops, no, actually, sorry. No. You don't actually need to do anything. Yeah. So probability x is less than a, and the probability of x is less than a. You just use the calculator directly. You don't need to change anything. From my memory, that was the case. So I hope this part makes sense, and that is for part A. That's weird. In a new poll, 28 people are found to support the candidate. Now comment. So, 28 people are found, and we are asked to comment on this one. So every time you say comment, then you can see that it's likely to relates to part A. A tip is that if in the exam you don't know how to do, maybe like part B plus C plus D of the question, then think about what you just did, or the answer you got the previous question. No, not previous question, previous part of the question. Now, this is because basically I feel like for me personally, the old A level, they would like directly tell you that you need to follow part A, like use the results from part A. But I feel like for the new A level, they don't say that. They want you to find it out and figure it out yourself. So I'm telling you this so you can save a lot of time from not making the mistake I did by just feeling like I'm lost. And that, yeah. Okay, so what's the question? So basically 28. Okay, so from part A, we found that the critical region is 24, and 28 is bigger than 24, therefore is within the critical region. Therefore, it's within the critical region, so we can reject H0, the null hypothesis. But remember context. Okay, remember the context. I made this mistake again and again, and it's frustrating. Now I can just always remember the word context. Whoa, so what should I like context? Yeah. So context plus. So after saying that 28 is bigger than 24, therefore it is within the critical region, and we can reject H0, the null hypothesis. And there is evidence that the candidate's level of popularity has increased. Okay, so it has increased. People are more popular. I mean, the candidate is more popular because of saying that he is going to support local charities. So that is for one type of test. So the main thing really was just going through a question and just using that, and yeah, just using that. But like, it's going to be the same for two-tail tests, and so there's nothing really new about two-tail tests, but I would still go over that. So yeah.